Good day everyone, today we are presenting our final project titled Advanced Network Architecture with DHCP and EIGRP optimization. This project focuses on the development of a reliable, scalable, and secure network infrastructure designed especially for the operational needs of Next Lane Logistics. Next Lane Logistics is a company that relies heavily on fast and accurate communication across multiple locations. Nextlane Logistics operates in three major sites across Luzon: headquarters in Makati City, which serves as the central management and decision-making hub; Branch 1 in Quezon City, responsible for handling customer coordination and logistic processing; Branch 2 in Cavite, which functions as the company's main warehouse and shipment center. Nextlane network objectives. First, the network must deliver high performance, ensuring fast data transfer and smooth communication between the headquarters, branches, and warehouse. This is essential for updating shipment records, managing inventory systems, and coordinating customer transactions in real time. Second, the network must support scalability, allowing the company to easily expand its infrastructure as it grows, whether Nextlane opens new branches or integrates new devices such as scanners, servers, or CCTV systems. The network should be ready to accommodate future upgrades without major reconfiguration. Third, robust security is required to protect sensitive customer information, shipping records, and other internal business processes. The architecture needs to include layers of protection that prevent unauthorized access and minimize cybersecurity risk. Finally, the network must ensure reliability, maintaining a stable connection among all locations. Since logistics operate on strict timelines, any downtime or network interruption could affect productivity and delay shipments. A dependable network is therefore essential for smooth daily operations.
Business networking requirements, reliable inter-branch connectivity, stable wide area network links for real-time communication and tracking, stable local network, strong local area networks for scanners, computers, and CCTV, centralized IP management, DHCP for auto IPs and static IPs for key servers, dynamic routing, use EIGRP or similar for fast, reliable routing, network security, apply VPNs, firewalls, ACLs, VLANs, and MAC filtering, scalability, subnets and capacity plan for future growth, network reliability, backup links and regular network testing, warehouse device support, ensure bandwidth and low latency for scanners and CCTV, IP addressing plan. Each branch gets its own IP range based on device needs. Makati supports 254 devices, currently using 7. Cavite Warehouse supports 126 devices, currently using 5. Quezon City supports 62 devices, currently using 6.
Network topology. This shows how all our company locations connect together. The central point is our main network hub. From there, connection branch out to our different offices and branches. The red line in the middle shows the main connection between our headquarters and other major locations. City Physical View. This is a map showing we are Hub Next Lane offices across Metro Manila. We have location in Makati City, our main headquarters with the building icon, Quezon City, and Cavite. Branch Networks. This shows our detailed network setup for 3 locations. Headquarters, Makati City, our main office network. Cavite Branch, our regional office network. Quezon City Branch, our another regional office network. Each location has routers, switches, and servers that handle our internet connectivity, internal communications, and data management for that specific office.
The Nextlane HQ router serves as the main hub, and all network communication from branches goes through this HQ for easier control and security. Serial 1 links each branch connects to HQ using a point-to-point link to ensure stable inter-branch communication. The DHCP is centralized at HQ. Branch routers use DHCP relay so HQ handles all IP assignments.
And for the subnetting, each location has its own subnet based on how many devices they need to support. And for the hardware setup, each location uses one router, one switch, and several PCs and laptops. And HQ also has a server. Ethernet cables connect devices inside each offices, and serial cables connect the branch to HQ for WAN links. DHCP, or the automatic IP assignment. Devices automatically receives IP addresses from the HQ router. The branch router forwards the request to the HQ. This removes the need to manually set IP addresses on every device. EIGRP, or the smart routing. EIGRP works like a GPS for your network, always finding the best path for the data. It automatically updates routes. If a link goes down, EIGRP quickly finds another path so the network stays on. Security, or the password protection. For the enable password, it protects admin access. For the console password, it protects physical access. And for the VTY password, it protects remote access.
So now, we'll walk you through how we configure the network devices, set up automatic IP addressing, enabled smart routing, and tested everything to ensure the system works even when problems occur. So, the initial setup was, we first created 3 locations for the next lane logistics. We have the headquarters in Makati City, Branch 1 in Quezon City, and Branch 2 in Cavite. Each location has one router, one switch, multiple PCs and laptops for employees, and the HQ also has a server for important data. So this one's the configuration of the HQ in Makati. We first set up the hostname and some basic configurations. The next thing we did was configure the Gigabit Ethernet interface, which has the IP address of 192.165.0.1. And after that, we configured the serial interface. It has the IP address of 25.0.0.1 and the subnet mask of 255.255.255.252. The next one is the Cavite router, same as the first one, and the Quezon City router. So we'll move on to the switch. So what is a switch? A switch connects all the computers, laptops, and servers within each location together, like a hub that allows all devices to communicate with each other. How we configure the switches? We set the hostname for each switch, like the Nextlane HQ switch, the Cavite switch, and the Quezon City switch. After that, we assign the VLAN IP addresses, like this one. We gave each switch a management IP address so we can access and manage them remotely. The Nextlane HQ switch gets an IP from the HQ network. The Cavite switch gets an IP from the Cavite network, and the Quezon City switch gets an IP from the Quezon City network. So let's move on to the DHCP configuration. So what exactly is a DHCP? A DHCP automatically gives IP addresses to computers, so you don't have to type them manually. We set it up by the HQ router, acts as the DHCP server, the one giving out addresses. Branch routers use DHCP relay to forward requests to HQ. When a when a router computer turns on, it automatically gets an IP address from HQ. So this one, and we have here the configuration of the DHCP. So yeah, this one here. Same. The two routers are the same as the first one. After we configured the DHCP, now we configure the PCs. For each PC, go to the Desktop tab, IP configuration, and then set the configuration to DHCP. You can see here the example. So let's move on to the EIGRP routing. So what is EIGRP? EIGRP is like a GPS for network traffic. It finds the best path for data to travel between locations. We configured it by enabling EIGRP on all 3 routers. Here, this command here we use it on all routers. After that, the routers automatically share information about available paths. If one path fails, EIGRP automatically finds another route. So we can verify now the EIGRP configurations by checking the neighbors by this command here. You can use it, and after that, check the IP route. So we'll move on to the security configurations. We have three types of passwords. The enable password that protects important router settings. Console password protects the physical access to the router, and the VTY password protects remote access when connecting from another location. So we have here the commands that we use for enable password, console password, and VTY passwords. We use the same commands for the two other routers. So yeah, bye.
Ping test. We check if all branches could communicate with one another by sending ping messages between the headquarters, Cavite, and Quezon City. With that, all locations were able to send and receive responses, confirming a successful end-to-end connectivity. While in DHCP testing, we verified that the DHCP server and the HQ automatically assigns IP addresses to devices in all branches. The added computers successfully received valid IPs, and the and release process worked properly. This confirms that the DHCP is fully functional across HQ, Cavite, and Quezon City. While in EIGRP convergent test, we tested how fast the network updates when a change occurs. By breaking a connection, we observed EIGRP quickly recalculate with new routes when the link was restored. The original routes reappeared. This shows that the network achieved fast and stable convergence. While in failover testing, we stimulate router failures by turning off the Cavite and Quezon City routers. Their routes disappeared immediately, and when powered back on, all routes were restored automatically. This proves the network can detect failures and recover without a manual fixes. While the last performance testing, we stimulate heavy traffic by sending multiple ping messages simultaneously and use a trace route to check packet paths that network handle all requests efficiently and showed clear routing paths. We also confirmed that the DHCP performance by ensuring renewal and assignment work properly.